Hi friends, this is Avinash joining the conference from India. Hope you are all safe and taking good care of you and your loved ones. So I am here waiting for the beautiful sunset in India and standing on my balcony and most excited to tell you about one of our recent private network deployments that we have done here. So yeah, let's get started.
So, a brief about me and our company. So, I'm the director for hardware engineering at CyberEye, and we are completely powered by IB Hubs, which is a team of 500 plus members. So, we primarily, as a company, we primarily work on solving challenges in critical sectors of government and industry. So, we are also a solution provider in terms of cybersecurity and IoT. We have also started working with B2B from past couple of years. So these are some of our main partners. So for Things Industries, we are the official partner for India. And for LoRa Alliance, we are a contributor member, and we are an authorized design partner for Microchip. So yeah, for the smart campus deployment. So this is done at a institution which is at the foothills of Himalayas. So that makes it more interesting. If you see the picture in the slide, behind the slide, so it is actually how the campus looks during winter. So we have when we went there, we had two main objectives in mind. So one of them is to optimize the campus energy consumption, which is very high because of the 80 plus big AHUs, automatic heating units they have, and hundreds of many heating units which are spread across the institution. So this is going to eat away a lot of electricity. So we had a task of optimizing the energy management, which in the campus. So along with that, we have also planned to create situational awareness while deploying our solution. We have focused on some of the parameters which are listed here, the consumption patterns of utilities and the room utilization, and tracking some key people and assets. So a pilot has been kicked off 2-3 months ago, and I'll show you more details on how it is going, and we can get some insights on uh, the recent installation also. So coming to the hardware part, let's start with the sensors. So we have installed two types of sensors here. The first one is a smart room sensor. So it can detect the movement, occupancy, temperature, pressure, humidity, and light intensity. So this will be powered with a battery of 2700 mAh capacity. It is configured to send the information for every 5 minutes, in addition to trigger-based information sending. Say, for example, it will send once in every 5 minutes all these parameters, as well as it will also transmit the information whenever it detects a trigger in its occupancy sensor, basically. So, to tell you briefly, it has a PIR. So, whenever there is a motion in the room, so it gets triggered, and all this information will be transmitted to the above configuration. So we have intentionally configured it to SFL to validate the battery capacity or battery lifetime of the device, as well as to do some interesting range tests as well. So the second sensor is the environmental sensor. Along with the temperature, pressure, and humidity, we also get the indoor air quality. Um, so the configuration stays same, and the battery configuration is also similar to what we have seen for the previous sensor. So these are the end devices we have used as part of our deployment, and we have also installed two gateways. One is an indoor gateway, and the other is an outdoor gateway. The indoor gateway is installed at a height in second floor of the total building, and the outdoor gateway is installed on top of the adjacent building. So I'll show you some pictures as well. So for both the backhaul is cellular, we don't want to depend on the local Ethernet setup, so that the gateways might, it might go into a black spot if they don't have if the Ethernet is down. So we have configured to cellular. So once the installation is over, we plan for different scenarios of the sensor testing and validation. So we had we had actually went there with a huge checklist, and also many of the test cases which have like before the deployment itself, we have done 2 months of intensive testing in multiple scenarios. We have analyzed the packet loss and we have tested the range of the sensor, and we have also did some study on how the battery life is, how the performance of the battery is, and the main challenge here is to check if there is any abnormal behavior like false alarm, specifically in case of PAR. So of course we have used the Things V3 stack. We have used the enterprise version of the Things V3, and yeah, let's see if I can show you some live data. Just give me a moment. Yeah. So this is the Things stack, CyberEye Things stack, and here this is the gateway, curling outdoor gateway, which is the outdoor gateway which we have installed there, and the gateway last seen at 20 seconds ago. So, and we are getting continuous events here. So good. Hopefully we should be able to see the live data as well. I think you guys are already familiar with the Things Enterprise stack. We'll go to the applications part where we can see the live data. Yeah. So we got two packets. So the time is 6:06 now. We got one at 5:58, one at 6:03. So let's see what the packet has. Yeah. Okay. So this is a timestamp. It was sent on a F port, and you can see the F count here. This has been sending information for every 5 minutes from the past 2 months. So the F count is around 14,745. Is the payload part, and you can see the battery voltage here, 3.64. It's actually very good battery level. Even if the transmission interval is, since the transmission interval is very aggressive, like for every 5 minutes, but still the battery voltage is 3.64. If you go the current temperature, there is 20, not bad. It was around 3 to 4 degrees when we went there. It will come down to 2 or 3 degrees during the night anyway. Yeah. So let's see the signal strength here. So the SNR is pretty good there. It's plus 13, and we have a reasonable RSSI of 100. And these are all the remaining information which you can see anyway. So let's go back to the presentation. So this is the live data which you can see, and yeah. So I'll show you some of the information on how we have actually installed the devices, and the challenges we have faced through the challenges we have faced during the deployment. So did you see them? So they were actually the Himalayas. We can see them right through our balcony. It was a pretty amazing view. So we have been busy configuring the gateways and sensors in the rooms, and then we have installed the gateway. So this is on top of one of the buildings. This is the way which leads to the lift room. So lucky that we got a lift room there where we have drawn power for the gateway. So we did not run down the wire all through the adjacent building. So there is one good thing which happened there. And if you see here, this is a corridor inside the building on first floor, and this is one of the sensor which we have installed here. So this is continuously, and it will be almost 40 to 50 meters away from the location we have seen for the gateway. So we have tested with multiple locations, and this is the location which least number of false alarms. Yeah. So once the deployment is done, we have tested, analyzed, and optimized the sensors for a couple of days. We had to move around at the position of, we had to move around the sensors, change their positions, and test in multiple scenarios. Me and my partner were moving in and out of multiple rooms. And particularly, it's about the PIR sensor, where if the room is well ventilated with sunlight, then it start to go crazy if we install it adjacent to a window. So we had to pick the place in a right way, and but we were pretty surprised, like to see the intensity of the good signal strength actually. For example, we have we have seen this type of deployments, and we have done this type of deployments in multiple scenarios in urban areas and rural areas. But because of the reduced noise levels and ambient temperature conditions, the RSSI and SNR were pretty good, even from the distance of about 100 meters or less, and completely obstructed with many of the rooms and buildings. even if the sensor is located deep indoor, we are getting plus 13 to plus 15 SNR on an average. I'll show you more of our like observations in our deployment dashboard. So this is one of the graphs. So this is how the number of so this for example, this is a device occupancy sensor which has been transferring the information from last 2 months. So the trigger, the uplink will be based on a trigger here. So if you see on some of the days the number of messages are as high as 300, and on some of the days it is very low, it is around 50. Okay, so it's because of the movement. It totally depends on the movement. It shows that the oxygen sensor is working fine, and on holidays it goes low, and on working days it goes high. So that's about it. And this is one more stat I want to show you. So these are all the uplinks we have received from the devices with respect to the channels. For example, sorry. So for example, we have 8 channels in Indian band in 865 to 867 megahertz in LoRaWAN. So the first 3 are default channels, and the additional next 5 are the additional channels. So here you can clearly see that there are more number of transmission happen in the first 3 channels. So curious about why this happened, I'll tell you shortly. So these are some of the indications. So let's show you in a live deployment dashboard. So this is a dashboard which we have built for ourselves at our company. So this is a custom made dashboard where we generally analyze all our deployment. See, for example, if we can select the device and we can select the gateway, and we'll get all the parameters which are displayed here. Let me take you to the uplink count specifically. Yeah. See, you can see that the uplink count of these first 2 devices are the occupancy sensors, and this device. I have taken a sample of 3 devices here just to like demonstrate one particular thing. And this is an environmental sensor. So these 2 devices will transmit based on the triggers of trigger. So every time a motion triggers, the transmission will happen. And in case of this environmental sensor, it will transmit for every 5 seconds. So if you see, the packet number of uplinks is varying on a high level in first 2 cases, because they are in different rooms, the graphs will be different. And but in this case, almost every day the number of transmissions are same. So that is a difference. That is the main difference on how a event based trigger and a continuous trigger will look like. And you can see that there is a drop here. There's a drop, unusual drop on number of packets which have been sent. So there is a reason. The gateway was down for more than half a day here. So that is one of the lessons we have learned. Since we have taken the power from the lift room, it is very unstable, and over the time the power got fluctuated, and the gateway was down for one day. We had to change the power source, and then it was working fine again. Yeah. So there are other statistics which I can show, but I think we are running out of time. So these are we can see the RSS SNR and all the metadata information here. Along with this, yeah. So here you can see that the first 2 devices are configured for the default channel, and the third device is configured for all the 8 channels. Okay. So all these 8, that's why we can see a significant increase in the like in number of packets in the default channel. So we had done this intentionally just to see how it will behave. We can see the number of packets here, total number of packets transmission with respect to each device, and these are the some of the graphs which we have, which will help us in understanding the RSSI patterns. So luckily, most of the SNR is positive. More than 75% of it is positive, and in almost all the scenarios. So yeah, I hope I can show you all the details about this dashboard, but yeah, let's skip to the presentation again. Yeah. To summarize, I want to share 3 important lessons here. So as I told, the clean power supply for the gateway is very important. It's very important for both for the performance of the gateway and stability of the total network. And the second important thing is, whenever you are working with a PIR sensor or occupancy sensor, that choosing the right place for the sensor deployment is the key here. and because they are very much prone to the false alarms, particularly when they are in external sunlight. We have taken enough precautions for these two issues, and we have done good in terms of deployment. It's been live from more than 2 months, and we are going to scale up the deployment very soon. So we have started with the HVAC systems, and we are going to extend it to water quality monitoring, and also we have been thinking of extending it to the outdoor environmental monitoring as well. Yeah. So we'll keep you posted about how it goes. I hope you guys will be in touch with me, and you can see more details on our channel. So yeah. So thank you guys. So that's it from my side. You can almost you can reach anytime. Reach out to me anytime. So this is my email ID. So have a nice day. Hope you'll enjoy the rest of the conference. And most importantly, stay home and stay safe. Thank you.